Let's take a look at this example from section 6.7. If Angela has $100 to invest at 10% per annum compounded monthly, how long will it be before she has $175? If the compounding is continuous, how long will it be? So we're looking at two different ways for interest to be compounded. Let's go ahead and notice that we have a principal investment amount of $100 right here. We have an interest rate of 10%, which is pretty unrealistic. And we have it's compounded 12 times per year because it's being compounded monthly. So let's go ahead and set up our compounded monthly equation. The initial investment amount is 100. And it's 1 plus the interest rate divided by the number of times compounded per year to the power of n, which is 12, times t. So the question is, how long will it take for this $100 to grow to $175? So we'll set the function equal to 175. And we're going to go ahead and solve this for t. So the unknown is in the exponent position. We will eventually need a log, not yet. First, let's divide both sides by 100. 1.75 equals 1 plus 0.1 over 12 to the 12t power. Now, in order to get this 12t down, we'll have to use a log or a natural log. I'll go ahead and use a natural log here. I'm doing that on both sides. The whole point of doing that is that now you can bring that 12t down to the front as a factor. So I have a natural log of 1.75 equals 12t times the natural log of 1 plus 0.1 over 12. I want to isolate t, so I can divide by all the factors over here on the right. So I'm going to divide by 12 times natural log of 1 plus 0.1 over 12, so that the 12s will cancel and this whole log will cancel. Of course, we'll be doing that on both sides. Now I can put this into my calculator here to get an approximation. So I put that in the calculator and I get about 5.62 years. So we want to make a comparison and compare this to the same situation, except if it was compounded continuously. So that equation would be P of t, or that function would be P of t equals initial investment amount times e to the 0.1t. We're still using that 10%. So we want to see how long it would take to get compounded to $175. The base here is e, so I will use natural log, but not yet. We have to isolate that exponential first by dividing by 100. Now we can use the natural log on both sides. Natural log of 1.75 equals the natural log of e to 0.1t. The whole point of using natural log is that it cancels with your base e here. And then we can just divide both sides by 0.1. And we'll go ahead and put this in the calculator to get an approximation. So this will take about 5.60 years. So slightly less time